Welcome back to another lecture from chapter 2. So last lectures, we talked about ARIO, how to use it, or RIO, and A stand for atom or electronegative atom, or resonance, I induction, and O orbitals. When you're using them, you should follow the technically the order or the priority. And in this example, we have ethanol versus the propylene. And I want to know, for example, I want to know if I have these two molecules. Okay. Is there any way to predict which one of them is going to be more acidic? So let's treat them with a base. So both of them, we're going to add a base to them. Okay. And I go base, and any base, it comes with a lone pair. So base has negative charge clearly. And if you don't write negative charge, that's fine. Okay. And then what do we get the other side? We get this. Okay. We get oxygen, and oxygen is going to have 3 lone pairs. Okay. Why 3 lone pairs? Because the neutral one already has 2 lone pairs, and oxygen is going to take those 2 electrons, and it will give the H plus to B, and B, it will be neutral, while this one, it will be -1. Okay. Now, where is the negative charge? Negative charge is sitting on oxygen. Now, let's compare it with the second one. The second one is going to give you such a structure. Negative charge, it will be on carbon. Okay. Remember, carbon, this carbon, the one I'm going to highlight, that carbon is sp3. The hybridization for it is sp3. Okay, why is it sp3? Because it has also 2 hydrogens there. Okay, and 2 sigma, like in 1 sigma with carbon, and sigma also with the red hydrogens, with the red hydrogen atom. So we do have 2 hydrogens there, and there is a double bond there. Okay, now carbon has a negative charge. Okay, I'm going to highlight carbon. Carbon has a negative charge. If I go with just electronegativity, clearly oxygen has higher electronegativity than carbon. Okay, so electronegativity says oxygen is more capable of handling the negative charge versus carbon. But we forgot one thing, and that's a resonance structure. Carbon is capable of forming this, capable of sharing lone pair with this carbon, and take those 2 electrons and give them to that carbon. And if we do it, this is going to happen. Okay, if we do it, we will get carbon attached to another carbon through a double bond, pi bond. And that carbon is already has 2 hydrogen atoms. So carbon will be active. Now, how about this carbon, the one I'm going to highlight? That carbon had 2 hydrogen atoms, and those are the 2 hydrogen atoms. Okay, so we're going to show those 2 hydrogen atoms, but carbon accepted a lone pair, and now this carbon will be -1. So I got 2 resonance structures. The question is, like, first one, ethanol has, with ethanol, electronegativity is favoring oxygen. With the second structure, resonance is still telling us that we can have 2 resonance structures. So now I have 2 factors. Electronegativity says ethanol should be more acidic. Resonance says the second molecule has 2 resonance structures. The more resonance you have, the higher stabilization, the stronger acid will be. Okay, but if you follow the order here, A, R, I, O. Okay. The A stands for atom or electronegativity. Because electronegativity comes first, that we have to stick with the fact that oxygen is more electronegative. So ethanol, it will be more acidic than the propylene. Okay, let's write the pKa for them. The pKa for this compound versus ethanol. Ethanol, it has pKa of 16. Well, the second compound, pKa of 43. Okay. Remember, lower pKa means a stronger acid. So lower pKa means stronger acid. And in this case, ethanol will be the stronger acid. Okay, stronger acid than the propylene. Okay. Next, should I really stick with this abbreviation or RU all the time? Okay, is there any chance maybe it's not going to be correct sometime? Yes. Okay, it's a good guideline, but it's not going to work all the time. Okay, and this is one example. Okay, carbon has lower electronegativity than nitrogen. So how about this? So electronegativity of nitrogen is higher than electronegativity of carbon. Okay, that means nitrogen is more capable of handling the negative charge. Okay, if I write the chemical reaction, in this case, the base is going to go after hydrogen, okay, and it will form H, C, triple bond, and then carbon, and carbon it will have a lone pair or a negative charge. Plus, I get NH3, and NH3 has a lone pair. Okay, remember, nitrogen had two lone pairs and use one of them, so still is going to have one. Okay, let's write let's talk about electronegativity. Okay, on the left side, negative charge is on nitrogen. On the right side, negative charge is on carbon. So I should say, nitrogen is more capable of handling the negative charge than carbon, correct? So technically, this reaction should not move forward, should not happen. That one should not happen. In fact, reaction should go this direction. Okay, that means this reaction is not going to happen. That's my prediction based on electronegativity. But then when I write the pKa of this compound versus pKa of the second one, okay? Let me say why the pKa of those two. Okay, this is going to be our acid, okay, because it's giving H, and this is going to be the base. If this is the base, NH3, it will be the conjugate acid. Okay, this is going to be the conjugate base. Okay, now we said in order to predict whether the reaction is going to move forward or not, you have to look to both acids. Okay, both acids. So I already found the acid. This is my first acid, the starting acid, and that's going to be the one we get it at the end, the conjugate acid. Okay, let's write the pKa for those two acids. The pKa of this acid is equal to, I believe, 30 something, 25. Sorry, 25. Okay, and the pKa of NH3 is 38. Yes, 38. Okay. Clearly, pKa of the product is higher than the reactant. And pKa says if you get a product with a bigger pKa, the reaction is going to move to the product side. So pKa is telling us the reaction will move to that side. Okay. Why? Because pKa of the product is 38. That's good. Why? Because it's bigger than pKa of the reactant, which is 25. Okay. Well, electronegativity says no, this one should not happen. Okay. Now, when I want to test whether this one is going to happen or not, which one I should trust, I'm going to run the reaction. Okay. Experiment is not going to lie. You mix them and you see you're getting ammonia, and also you get that base. So that reaction in reality is happening, and because it's happening, you're going to trust pKa. So pKa is the one that you followed, and pKa said the reaction will happen. Okay, reaction will happen. Okay, another one. Okay, so it says predict which one of this is more acidic. Okay, and we're talking about red versus blue one. Okay, and I'm gonna cover this equation in the next video. So I'm gonna pause here, and I will see you soon. Thank you very much.